Hi students, in today's video we'll talk about speed maths. A lot of you may think that speed maths is necessary, something that you should definitely have to crack the CAT, but that is definitely not the case. So let me answer that question, that do you really need to know speed maths to crack the CAT? The answer is no. So if you're not going to watch the rest of the video, you have the answer already. But let me talk about some of the important things to keep in mind, things that you should do even if you're not going to practice speed maths techniques as such. What are the must do things which will help you in calculating faster and solving questions faster? So let's get started. Now, couple of things before we get into what you should be doing. What is speed mathematics, right? So speed mathematics is your ability to calculate, compute at a above average pace, right? So at a pace which is normally what people might compute at. If you're able to calculate at a faster pace, then you will say, okay, fine, I am using speed mathematics. Now, all of these they come from the calculation techniques that are there in speed maths. They come from, majority of them come from Vedic mathematics, right? So if you look at Vedic mathematics, and there are enough books available in the market, a lot of people even offer programs, etc. if you want to study Vedic mathematics. Honestly, you don't need it for any of the competitive exams. So the minimal applications in competitive exams makes it unattractive for a lot of people. Also, you have to remember them, right? So all these techniques that are there, you have to remember those approaches. So rather than running behind the exact sutras which are there in Vedic mathematics, like Ekadikena Purvena, for example, you don't have to remember these names. What you have to remember is, okay, if there is a technique which will help me in a certain case, and most of these apply only for specific cases. So if you know that, okay, a technique like this exists, I can use it at the right time. Okay, so you should know some of them, but you don't have to remember the actual names of these techniques, and you definitely don't have to buy any Vedic mathematics books if you're preparing for any of the competitive exams. Okay, so what are the QA skills tested on the CAT? Now, on the CAT, if you look at, they are not testing your ability to calculate very fast. So let's say if you're somebody who will not be able to answer this question that I'm going to ask you very quickly, it's still okay. For example, if I ask you, okay, what are the last two digits of 76 square? Now, it's okay if you don't know how to do it, right? Because what you can always do is you can actually calculate 76 square. You can do 75 plus 1 the whole square. So you can do a plus b the whole square. You can do 80 minus 4 the whole square. So a minus b the whole square. But what you can also do is, if you know that, okay, 26 square ends with, which is 676. So that ends with 76. Even 76 square is going to end with 76. Okay, so some of these things you learn by doing stuff. So as you solve more and more questions, you start understanding some of these concepts, some of these techniques as well, that you pick organically rather than somebody actually sitting and teaching you those techniques. Okay, so what is tested on the CAT is your ability to deconstruct the problem. So what exactly the problem is asking you to do and solve. Now you can do it either in a systematic way, or you find a smart way to answer a particular question. For example, you may see that in the question everything is a multiple of, let's say, 4 or 6, and finally in the options you see something which is a multiple of 24. So then you go with that, right? Because you think, okay, fine, because it is 4, 6, so maybe 24 or a multiple of 12, so you can go with that. This is a smart way of approaching the problem rather than actually solving it systematically, and that is what CAT is testing. So most of the time it is testing whether you know how to do it in a standard way. In some cases, you can either scale down the problem to a manageable level and solve it, or you can solve using options, etc., which falls under the smart approach of solving questions. Then ability to calculate at a reasonable pace. Okay, and this is without any errors. So if I, let's say, ask you to do, say, 13 into 31, for example. Now, how quickly can I do it? Correct. Now, somebody might be super expert at this, so they'll be able to calculate very quickly. Some of them may have done things at the school level, which has helped them to get faster. But do you need that for CAT? Because if I have 13 into 31, I can always do a 13 into 30, which will give me 390. And then I add another 13 to it, right? So that's the end of the whole thing. So I will be able to do a lot of things, right? I can do 31 into 10 plus 31 into 3 as well. Now this, as long as you're able to calculate without any errors, you are fine. So don't take too much pressure if you're not able to solve some questions. For example, nobody is going to ask you, okay, 93.7 square it and tell me what's the exact answer. Because there is one side which is basically human calculators who will be able to do it, but do you need to be that to crack the CAT? The answer is no. Your ability to approximate is very important. So 13 into 31, right? Let's go back to that example. Approximately, I should know that this is going to be around 400. If I know that much, I am good to go for CAT. I don't have to know the exact thing as well. And then ability to execute things fast. And that will come with practice. See, most of the questions when you look at them, right, as you keep doing those questions, similar questions and all of that, you start remembering those approaches and then the execution becomes fast, correct? It's like, say, if you're learning something for the very first time, right, you will struggle a little bit, you will take more time to do that task. But once you know it, right, it kind of becomes like a code. So you know what exactly to do when, what to do, and then what is the next step to be done. If you encounter a problem, then what you are supposed to do, right? So all of this starts falling in place because of repetition. So more questions you're solving, the execution time starts going down. So for these techniques as well, it's the same thing. So when I teach you a technique for the very first time, right? Let's say I teach you how to calculate 103 square, and I tell you, okay, 103 is 3 more than 100. So you write it on the right hand side. So 3 into 3 is 9. You should have 2 digits on this side of the partition. So 09. 103 plus 3 is 106. So 10609, that is the answer. Now, once I've learnt it for the very first time, I've understood it properly, I should repeat it. So whenever I get an opportunity to calculate something similar, let's say I ask you to do 107 square, which is going to be 11449, I will apply the same thing and execute it faster. Try and push yourself to execute faster, and that is how you will get overall faster when it comes to solving and calculating stuff, okay? So you need to practice it a lot. Even if you are going to learn some of the techniques, you'll have to practice them very often to get better at them. Now, let's say, considering we already established that you don't have to study Vedic mathematics or speed calculation techniques, still you will have to do a few things which are important, starting from the first thing, which is going to be some particular shortcuts and techniques, right? These are very, very important. For example, squares of numbers ending with 5. Because it's a very commonly known thing as well. Most of the CAT takers would know it. So you don't want to be somebody who doesn't know it. So for example, if I want to do 35 square, the 5 ending, that becomes 25. 3 into the next number, 3 into 4, 12. So 1225, that is the answer. So that's a very simple technique. Anybody can learn it in like 5 minutes, right? So please do that. Then multiplication with 9, multiplication with 11, there are enough shortcuts for that. Finding squares, right? So one of the techniques I just showed you. But even for say 2-digit numbers, 3-digit numbers, larger 3-digit numbers, you have different techniques that can be used. They can be numbers close to a base. For example, a 501 square, right? There's a technique to do that. Or I can split it as 50 and 1 and then solve it. So again, that's a separate technique to do it. So there will be multiple techniques to do the same thing. You try and learn whatever you can, but if a question is thrown at you, whatever strikes you the first, just follow that particular approach because that's going to be the best approach. Then multiplications close to a base, right? Just one of the examples that I gave you, 107 square. But if you can do 107 square, you will also be able to do 94 square, okay? Because that is also closer to 100. Or say think of 1012 square, very easy to do. Same principle, right? So I think it will become 1024144. I'm just executing things fast at this point of time, correct? So it's not that I remember a lot of Vedic math or calculation techniques, but whatever I've done, I'm just able to execute it faster. Then building blocks. And a lot of students don't do this, and then they think that this is what I should be focusing on. But the core is this, right? If you know this execution will get faster. So building blocks is what? 1 to 30 tables. Ask yourself genuinely if you know tables from 1 to 30. Okay, if somebody wakes you up at 2 o'clock in the night and says, okay, fine, tell me 29 into 7, you should be able to answer it. If you don't know what it is, then please go ahead and study this. Very, very important. Then 1 to 30 squares. Okay, so if somebody says, okay, tell me what is 23 square, you should know that it is 529. Then 1 to 16 reciprocals. Now, what I mean by reciprocals is, let's say 1 upon 1 is 100%, 1 upon 2, 50, 1 upon 7 is 14.28%, and so on and so forth, because that is very useful when you do a lot of DI sets to approximate. So fraction percentage equivalence is something that you should look at. And then finally, powers. So powers are very important because even logarithm questions, you will see applications of this. So up to 12 for 2, which means you should know from 2 raised to 1 till 2 raised to 12. Up to 6 for 3, so you should know till 3 raised to 6, 4 raised to 6, 5 raised to 6. Those are the numbers to look for. Then for 6, 7, 8, 9, 10, you should know powers up to 4. So 9 raised to 4, for example, you should know that it is 6, 5, 6, 1. Then up to 3, so cubes for 11 to 16. So from 11 to 16 onwards till cubes, if you remember. So all of this is important, required for you to be somebody who can do reasonably well in competitive exams wherever math skills are tested. So if you do this, right, then you don't need any other additional techniques and all of that, right, because this is going to be something that will make you fast. Okay. Now, one last thing, always use a calculator if needed. Now, CAT gives you a calculator, right? So you might as well use it. And in fact, if you look at CAT 25, there were a lot of questions wherein you needed a calculator because they were frustrating to calculate. Even somebody who is fast, considering somebody who knows all of this, that person was also struggling. In such cases, it is important that you use the calculator. So don't try to take it on your ego that I'm not able to solve it, which maybe otherwise I'm able to calculate fast, but I'm not able to solve this question. So don't take it on your ego. Use a calculator, but use a calculator where you get it in CAT, but let's say in something like an NMAT or a SNAP or a CET, it's not going to be there, and that is why you will need these techniques and the building blocks that we spoke about. So how to get better, right? First is going to be muscle memory. You have to repeat these techniques n number of times, right? So I learned a lot of these things when I was in school. Now some of you may have done that, some of you might be learning these things for the very first time. Special cases, for example. So 33 into 37, right? Now 33 into 37 is just an extension of 35 square. So when you do 35 square, you do 3 into 4, the next natural number, and you do 5 square, 25. 5 square is nothing but 5 into 5, correct? It's multiplying those numbers. So if I give you the case, which is a special case where the tens digit is the same and the units places add up to 10, 33 into 37, for example, you will be able to do 3 into 4, which is 12, and then 3 into 7, which is 21. So the answer will become 1, 2, 2, 1. Now, all of these special techniques, if you know, right, some of them at certain places, it might help you. And the more you practice them, the more you will be able to spot it. Otherwise, you will not be able to spot it, even in the paper if it is obvious. I would say 5 to 10 minutes of daily calculation effort is good enough for anybody. Now, what you can do, right, is take a piece of paper, and on that you can just start writing whatever numbers that come to your mind, right? And I'm just writing it in the form of questions. For example, I can write, okay, 47 square, 31 into 97, 421 minus 627 plus 143, and so on and so forth. So I just write, say, 10 problems, and I push myself to solve them without writing too much. Because the moment you start writing, you will go back to the typical methods that you have. And that is why force yourself to do it without without pen, right, as much as possible. So 5 to 10 minutes, good enough, just 10 problems, about a minute average per question. Overall, you will see that once you do it for maybe a month or so, automatically you will start getting better at calculation. Because see, all the basic elements, if you have those in place, right, then calculation time will start going down and you will feel good about the whole progress that you have made. And finally, one very important thing is calculate whenever possible. See, all of us get opportunity to calculate things, but we don't, right? Because we rely on technology. So I'm saying you need to get rid of your calculator. Don't use it on your phone as well. GPS, for example, a lot of people use Google Maps, etc. when they're traveling somewhere. But if you can look at the car's average speed and you have, let's say, a milestone which shows that so much distance is remaining, you should be able to calculate the time that you're going to need, right? So let's say you go to the mall, right, and you see a store which is offering, say, a scheme which says buy 5 get 2 free. Can I calculate the percentage discount, right? You look at, you go to a mall again or a store, you buy a lot of things, right? So don't wait for that person to scan each and every product and take a total of it. Maybe you're purchased 4 items, right? One is 31 rupees, the other is 57, the other is 101 or whatever it is, right? Just you take the total before that person says, okay, fine, this is how much you need to pay, right? But of course, if there are any discounts or something that is going on, you wait for that person to say, okay, this is the amount, and then you pay it. Otherwise, don't be over smart and pay them extra. Time required to reach your destination, right? As I said, you are traveling at 60 km per hour. You see that there's another 150 kilometers to go. Why don't you do 150 upon 60 rather than relying on your GPS, your Google Maps to tell you that, okay, this is the total time or the ETA, right? So all these small opportunities that you get on a daily basis, even if you just calculate within these opportunities, you're going to get fast. Because then the natural tendency that we have to reach our pen and start solving, actually writing a lot of steps, etc., that thing will start shifting towards you calculating without taking much of stress, right? So make it a part of your routine. That's what I wanted to share. Just 5 to 10 minutes of daily effort is good enough. Okay, you don't have to do anything beyond this, and definitely you don't have to buy any Vedic mathematics books to crack the CAT. Okay, so that's it for this video. I hope it has helped you and given you a new perspective or changed your perspective. So thank you so much for watching. Wish all of you all the best, and I'll see you soon.